which is vectors. So we need to use vector analysis to resolve a vector into two perpendicular components. And then we need to solve vector problems by resolving vectors into components, adding or subtracting the components and recombining them to determine the resultant vector. So we're going to go over how to do these steps now, but something you should keep in mind if you're kind of going, oh, vectors are easy, kind of rolling your eyes a little bit, is this content actually becomes very important. I mean, of course, in projectile motion, which you've probably touched on, but also in electromagnetism. The vector analysis is actually really important in electromagnetism, and it gets into more complex vector analysis, kind of involving all of the trigonometry rules like the sine and cosine rule. So my point is, it is actually really important to understand this stuff and to work on it a little bit instead of just kind of like shrugging it off. Because I know that's what I did in year 12. And then when I got to electromagnetism a little bit, I was like, ooh, what does this even mean? Okay, so resolving vectors into components, as you can see here in our diagram, requires the use of our trig ratios, our sine, cos, and tan, which hopefully you guys remember from your math subjects. So, our vector, of course, forms a right angle triangle with the adjacent and opposite, or rather with the x and y components. So that's why we can use our trig rules. So what this basically tells us is that the x component is going to be equal to the hypotenuse multiplied by the cos of the direction, or so on, applying these rules. The other law that you can use to apply to resolve vectors into components is Pythagoras, where of course you need to let the hypotenuse equal one side and then the opposite and the adjacent squared on the other side. Okay, now getting into a little bit more of what a vector is. So vectors have both a magnitude and a direction. So a lot of the quantities that maybe you've worked with up until this point will just have a magnitude, such as 5 kilometers, 3 kilograms, 3 meters per second, stuff like that. However, a vector has both magnitude and direction. So it will be 3 meters south, 5 meters per second to the left, 3 meters per second at an angle of 30 degrees. They all include directions. So our vectors can be resolved into components, and to resolve with these vectors, we need to resolve them into components using our trig, and then add and subtract these components, and then find the vector sum. So I won't go over a too in-depth example of this, just because we are going to get into applications of these in our next topics. But really quickly, what these steps are kind of describing is if you have, say, two vectors like this, and you wanted to add them to find the resultant vector, this green one here, what you would need to do is you would need to find the horizontal and vertical components of each, and then add the horizontal components, because of course that's going to give you the total horizontal component, and then add the vertical components.